you're given a graph y is equals to x squared plus a over 4 minus x. Now, you are asked to state its asymptote. Now, you look at this expression is a improper fraction. To find its oblique or the horizontal asymptotes, you have to do a long division, and now I shall not bore you with the working of the long division. Now, if you do a long division, you will get minus 4 minus x as its quotient, and the remainder will be given by 16 plus a. So this equation can be rewritten as minus 4 minus x plus 16 plus a over 4 minus x. Now this portion of the equation, this portion, the quotient, will be the oblique asymptote or the horizontal asymptote. Now in this case, it's oblique asymptote because it's in the form of y equals to mx plus c. So the oblique asymptote will be given as y equals to minus 4 minus x. And for the vertical asymptote, it's very simple. You look at the denominator and you equate the denominator to 0. So the vertical asymptote will be given by x equals to 4. Now let's move on to the second part of the question. Now you are given a graph that has a turning point at x equals to 1. Now what does that mean? All turning point has gradient 0. That means you are given that dy by dx equals to 0 at x equals to minus 1. You are asked to show that a is equals to 9. Now this second part of it is rather simple. So you just follow the given instruction in the question. Now dy by dx equals to 0. So we do a differentiation to this equation. So dy by dx will be equals to minus 1 plus 16 plus a over 4 minus x squared. Now it is easier to differentiate this rather than this because this involves quotient rule. So there's a lot of simplifying to do. Whereas here, this is a direct differentiation. Here you just do a chain rule and you will come to this. Now dy by dx equals to 0 and x equals to minus 1. All you need to do is you substitute x equals to minus 1 into your dy by dx, and you equate that to 0. You bring this over, you do a cross multiply, you will get 16 plus a equals to 25, and a will be equals to 9. Now you are also asked to state the rest of its turning point. Now for turning point, dy by dx equals to 0. So you equate this, minus 1 plus 16 plus 9, because we already found that a is equals to 9, over 4 minus x squared is 0. So you will get, you bring this over and you do a cross multiply. So you got 25 will be equals to 4 minus x squared. Now you square root both sides, you will have x minus 4 equals to 5, or x minus 4 equals to minus 5. Now then you will have x equals to minus 1 over here, and x equals to 9 here. Now these are the x coordinates of the turning point. Now for the y coordinate, it's very simple. Now you put 9 into this equation over here. And you have 81 plus 9, because we already show that a is equal to 9. 4 minus 9. And what will you get? You got minus 5 here, 90 here, so you got minus 80. So there's one pair of the coordinates. Now the other one, when x equals to minus 1, what is the value of y? You have y equals to 1 plus 9 over 5, and you get 2. So this will be the other set of the turning point. Now for the last part of the question, you are asked to show that you are asked to find the range of values of k, so that x squared plus 9 over 4 minus x equals to k has no solution. Now, there's two ways to do this part of the question. One is the discriminant method, and the other one will be the graphical method. Now, I shall do the discriminant method first. Now, if you do a cross multiply, you will realize that this is a quadratic equation. So you can do by completing the square to find the range of values of k, or you can use the discriminant method. Now for today's exercise, I will just do by using the discriminant method. Now if you do a cross multiply, so you will have x squared plus 9 equals to k into 4 minus x. Now then this portion will be equals to 4k minus kx. Now you bring this over, what will you get? You will get x squared plus kx plus 9 minus 4k equals to 0. Now your graph will look, for this graph, it will look something like that. Alright, you doesn't want to have any solution, so there will be no roots. Alright, so the b squared minus 4ac, or the discriminant for this quadratic equation, must be less than 0, and this is what you learn in Sec 4. So if you, for no solution, no real solution. So if you do this b squared minus 4ac will be k squared minus 4 into 1 into 9 minus 4k is smaller than 0. And if you expand this, you will have k squared plus 16k minus 36 is smaller than 0. Factorize it, k plus 18 into k minus 2 is smaller than 0. Right? And you got minus 18 is bigger than k but smaller than 2. Okay, this will be your solution for the last part of the question. Now we will then now use the graphical method to do the last part of the question. Now the last part of the question can also be done using a graphical method. Now you are asked to state the value of k so that this equation does not have real solution. Now if you look at this, this is two graphs. Alright, one, you have this graph, and the other one you have another graph y equals to k. Now what is y equals to k? Y equals to k is merely a horizontal line. Now what you can do is you can key this particular equation into your graphical calculator. Now earlier on we find that you have asymptote at x equals to 4. Now let me use a different ink. So you have 4 here, and you have a oblique asymptote where y is equals to minus x minus 4. So it cuts the y-intercept at minus 4 and it's slanting this way. So this part will be 4 because it has a gradient of 1. Now if you key into your calculator, your graph will look something like this. This is an asymptote, so it will get closer and closer. Alright, then this part will look something like that. We'll get closer and closer to this line. Now what is the lowest point here? The minimum point. You have your coordinate minus 2, 1, which we have found earlier on, and this part is 9 minus 18. Now if you draw any horizontal line, y equals to k is a horizontal line. Now if you draw any horizontal line that is in between 2 and 9, 2 and minus 18. You draw any horizontal line in between 2 and minus 18, non-inclusive of 2 and minus 18, you will find that it will not intersect the green curve. Okay, you draw a horizontal line here, y equals to k. So the answer for k, so that there's no real solution, will be in between with minus 18 and 2. For that, we come to the end of question 1.